Today's lesson is a continuation of section 4.3, graphing using intercepts. We've been working on using, as I call it, method number 2 up here in our red list, graphing using the x and y intercept. We also don't want to forget about the first method too, finding some ordered pairs. Today what I'm going to show us is that it doesn't matter really which method we use to graph an equation. Either way, we should get the same exact graph. So if a student, or if you're more comfortable with one of the methods as opposed to the other, that's actually not a big deal. I like to show us both methods, and I want us to be able to use both methods because sometimes one's easier than the other. One will be less work to get to the answer than the other will. So I want us to be able to understand that both of them are just as good and both will get to the same answer. But it is okay if there's one that you're a little more comfortable with. That is fine because either one would work in any situation. So for example, I'm going to go through this example problem right here. It says graph the following equation, and here's our equation, 3x plus y equals 9. So first, what I would say is, if I'm looking at this problem, I think the easier way to graph it would probably be using method number 2, using the x and y intercept. This equation's in standard form. X and y are on the same side. Those terms are on the same side. And on the other side, I have some constant, like 9. So then this equation's in standard form. It's usually a little easier then to use the intercepts method, or at least this one, it's set up well for that method. So I'm going to use method number 2 here to graph this equation. Well, how do I do that? Again, what happens with intercepts method, essentially I plug in 0 for x and I plug in 0 for y, and those help me find my two intercepts. When I plug in 0 for x, it's like a point where I haven't moved left or right at all, but I'm going to move up or down somewhere on the y-axis, so that's my y-intercept. When I plug in 0 for y, my second point, that'll be like a point where I move so far left or right, but I don't move up or down at all. So then I'll be on the x-axis, so that's my x-intercept. So again, that's the idea behind the graph and using the intercepts method, is I find the 2 points that are, each point that's along one of the two axes, and then I have my 2 points to graph my equation. And they're easy to find when the equation's in this setup. So first I'm going to execute the first point here, find my first intercept, where I plug in 0 for x. When I do that, again, as I often show on the board, I just cross off the term with x because 0 times anything is just going to give me 0. So essentially, this 3x is just gone from the equation. What do I have left? I just have y equals 9. So then that's my y-intercept, 9. So 0, 9 is my first point. If I go down to the next part, I'm going to plug in 0 for y and see what that gives me. When I put in 0 for y, again, what I think of is I just cross out y because if it's 0, that means it's not going to affect our equation at all. Well, what's left? Well, now I have 3x equals 9, and if I divide both sides by 3, I get x equals 3. So my other intercept, when I plug in 0 for y, I get 3 for x. So my other point is 3, 0. So there's me using the intercepts method to graph this equation. Again, these are just like two ordered pairs. They just happen to be right along the x and y axes. 0, 9. That'd be if I go left to right 0 and up 9. 3 zeros goes to the right 3 and up or down 0. So there's my equation. And here's what the graph of my equation could look like. Okay. So again, using method number 2, using the intercepts method, that's what my graph should look like up to this point. But now what I'm going to do, and talking in the class, I'm going to ask the students, what would happen, let's say if I instead wanted to do this problem using ordered pairs method. Would that make a difference? Would my graph of my equation look different? Would it look the same? Would it be a different slant? Would it be steeper or flatter? What would happen now if I go back and graph this same equation using method number 1 instead? I'll ask that question to the class and see if anybody has an idea. And what I usually find is somebody will kind of, as I talk about it, will kind of figure out that, well, both these methods, again, just like we talked about with solving equations, there are different methods to get to a result. And same thing with these two methods. It doesn't matter which one I should use. Either one should give me the right answer. So in this case, people do kind of start to figure out, well, then I should get the exact same line, the exact same graph when I use even method number 1. It shouldn't matter whether I use ordered pairs or intercepts. So let's try it out and see if that does work. If I try to use method number 1 for this equation, well, what do is that we usually talk about then trying to get y by itself, or solving this equation for y so I can plug in some points. I'd have to subtract 3x from both sides to make this happen. So I subtract 3x, it gets rid of it from the left side. Now y is all by itself. On the right side, I have negative 3x plus 9. So now this equation is set up well for ordered pairs method for the first method. If I put in numbers like 0, 1, and 2, again, you can pick whatever you want, but I usually just pick 0, 1, and 2 because they're easy to plug in. If I put in 0, negative 3 times 0 gives me 0, plus 9 gives me 9. And again, just kind of showing that work. Because again, I probably should kind of show what is happening here. When I put in 0, like I showed there, negative 3 times 0 essentially cancels that part out. Plus 9, though, gives me 9. When I put in 1, negative 3 times 1 gives me negative 3, plus 9 gives me 6. And when I put in 2, negative 3 times 2 gives me negative 6, plus 9 just gives me 3. So there are my 3 ordered pairs now. Kind of showing my work, but there are my 3 ordered pairs using method number 1. I'm going to graph those 3 ordered pairs. 0, 9, right there. 1, 6 would be about right here. And 2, 3 would be right here. And what do you know? Okay, just like we were talking about, if I graph this nice and go through all the points, I find that the green line looks just like the blue line, just kind of as I was showing up here. Green line is me graphing with ordered pairs method. Blue line is me graphing with intercepts method. And what do you know? I get the exact same line. Okay, so again, that's what I want the students to understand today, or get out of today's lesson, is to realize it doesn't matter which method you would use. Just say all of a sudden you start using intercepts method for one, or just say you start using ordered pairs method for one. Either way, they're just different routes to get to the same answer, to get to the same graph of the equation. We're then going to go through this little chart and kind of talk about, well, which equation or which equations are set up good for ordered pairs method and which equations are set up good for intercepts method. Again, I want us to be able to use both methods. I want us to realize that it wouldn't matter which one. If I really was comfortable with ordered pairs, I could always use ordered pairs. If I was really comfortable with intercepts, I could always use intercepts. But I do want us to be able to use both because sometimes one's easier than the other. And again, that would make less work for us. I don't want us to have to go through so many steps. I know steps take a longer time, have a higher probability of students making some little mistakes because just you have to go through so many steps. So if there's problems where you can only have to do like one step, or even just start graphing, well, you probably got a better chance of getting the answer right because you don't have to do as many steps to get to the answer. So I want us to be able to use the method that looks to work the best. It looks like that equation is set up for. So if I look at the very first problem here, or this first equation, it says y equals 10 minus 7x. This equation is solved for y. Y is all by itself on the left side. So as we've talked about in this chapter so far, that's probably a better equation to solve or to graph using ordered pairs because I can just plug in 0, 1, and 2 quickly. I can put in 0, 1, and 2 for x and get answers out quickly by just taking 10 minus whatever I get there. And that'll give me my 3 ordered pairs. So that's probably one that's set up better for ordered pairs. Could you use intercepts? Sure you could. But I think ordered pairs would be a little easier for that equation. Okay. The next one's in standard form. X and Y are on the same side. So this is an equation I would like the students to use intercepts method with. Since that one I can just plug 0 in for X and Y, find my 2 intercepts and graph and go ahead and keep moving on. Same thing with number 3. X and Y on the same side, so I say that problem is better set up for intercepts. And number 4, again going back to the first method, this one's solved for Y, so this one's probably better for ordered pairs. Some of these ones at the bottom now, I've made little changes here. And again, realize there's no wrong answer for any of these problems. You could use any method, it wouldn't matter. But this next one, it's not perfectly set up for intercepts or ordered pairs. I would have to change things around to get it set up for either one of the 2 methods. Looking at this problem though, I think the easiest change would be if I just subtracted 6y to both sides. That would only be one step. And now what would I have on the left side? I have 3x minus 6y equals negative 12. Now it will be set up good for intercepts method. And I only had to do one step for that. I could do ordered pairs method too. I could solve this for y by adding 12 to both sides. I can add 12 to both sides. I'd have 3x plus 12 on the left side equals 6y on the right side. And then if I divide everything by 6, I would get 1/2 x plus 2 equals y. So I could also solve it for ordered pairs method and get it so y is solved for y and y is by itself. So notice, either method would work. Which one I think is easier for this one though? I would say intercepts method because that only took one step to get it ready for intercepts method. Then next one, number 6. It's just kind of a little bit of a tricky one just because the x is on this side and the y is on the right side. But really this equation is still solved for y. Y is by itself. So this one I would also say is still an ordered pairs method problem. That one I would still say is it's the easiest way to figure that one out, or to graph that equation. 7 minus 2y equals 10x. This one also would just take one step to set this up for intercepts method. I would just add 2y to both sides. So I'd say this one's probably better suited for intercepts method. I like this next one because we sometimes even debate about this one back and forth in class. Which method could you use? This one also is a perfect example of you could use either method. If I divide everything by 3, if I divide each term by 3 in the equation, now I have y equals negative 4x plus 8. And now it's set up well for ordered pairs method, which I think is a pretty easy step. I just got to divide everything by 3. If I want, though, I could just add 12x to both sides. 12x plus 3y equals 24. And now it's set up well for intercepts method. So this one, one step either way would be fine. And so this is definitely a problem where whichever method you feel comfortable with, you could go with on this particular problem. I think I'm going to say ordered pairs for this one, though, just because I think divide all those numbers by 3 would probably be a nice, easy way to get this one where y is by itself. So I think I said ordered pairs for that one, but just realize again, there's no wrong answer. I could use either method, it wouldn't matter. And then that last problem, this one also is in standard form, so I'd say this one's probably better for intercepts method. But I want people to be comfortable using either method. Just realize there's no wrong answer. Just sometimes a suggestion on which way we should go. Today we'll practice some more of this too, being able to use each method and be able to be comfortable graphing with either of the two methods and switching equations around so that I could use either method.